Thank you very much. So thank you for having us here, BruCON and Belgium. First time in Belgium for me, at least. A little disclaimer: we just came here yesterday. Actually, we came here like 3 days ago, and then a conference in London asked us to speak there as well. And they said just arrive somehow. So we rented a car, and then we discovered that the bridge that takes you, the train that takes you between Belgium and England costs 250 euro. What is this? Like, what am I doing? Like, fucking valet everything. Like, give me the first class. No, you just sit in your car, inside a train. You have no bathroom, nothing. You just sit there until you reach England. So then we came here yesterday. We landed around, I don't know, like 10:30. People were also already rocking at the party, right? I saw many of you. Who was at the party yesterday? Good. Who was dancing yesterday? No one raised a hand. I know. I was in the party. We came there around, I don't know, like 11:30. You were rocking the boat. Everyone was on the dance floor. So a little recommendation for everyone. If you come to a party and there's music, try to a little bit. So, okay. Now that we've passed our hangover, we can go with the talk. So, dissecting non-malicious artifacts, taking files which are non-malicious, non-malware, finding them where actually malware reside, and find some IPs in there and not internet protocol, intellectual property. So this is what we want to show you today. Maybe some of you are already familiar with it, but we took it to the next level, and we created a tool for actually proving that what we're saying is not bullshit. So believe us when we say what there is in this presentation. A little introduction with us. My name is Ido and this is Dani. We're both co-founders of VirusBay. Anyone know who VirusBay is? Okay, I'll try again. Please, everyone, raise your hand. Everyone know what VirusBay is? Yeah. So basically, it's a hub for malware researchers. If you're not there yet, look for VirusBay online and just join us so you can actually switch malware like you should. I'm a senior researcher at a company called Kaspersky Lab at the great global research analysis team. And then he has his own company. I'm an alumni of a college in Israel and volunteer as a computer science lecturer. It's funny, you should come. And Dani is a student in Berkeley. Since I'm so old, I have 3 daughters. Dani is very active on Tinder. But it's for research purposes, so don't worry. Nothing comes out of it, I can assure you. We're originated in Israel. Probably you've already noticed from the accent. And a little disclaimer, so after we published some of the materials of our research, that mainly in the bottom line says that security solutions are exfiltrating data of their clients somewhere to the cloud. Then a few companies called us, let's say XYZ. Some of them has 3 letters, and they said, stop. And we said, okay. And so we deducted a lot of the slides in the talk, mainly those who exposed some information, either on the companies themselves, the solutions, or the data which was exfiltrated. But we will show you like a little example which we got approved from one of the online sources. So the research motive. Basically what you see here is an email of password reset, which was originated in some company in Sweden and somehow got to the internet where malware should reside, and it was detected as spam. It was detected as spam because of some spam filter, very known one, by the way, and we thought it was just like a one-case scenario. But after we applied some of Dani's knowledge in machine learning, we found out that there are like tens of thousands of the same origin, of the same spam filter. And not only that spam filter, we found other spam filters and other solutions which actually is supposed to defend the client, and somehow these files were found online. Some of the headers that we found for these companies, over 10 companies at the moment, are in front of you right now. Of course, we deducted the names. Yeah, you know, we wanted to expose them. And so the concept we are coming from is that data can be extracted from a lot of places. Mainly us, the employees. We suck. We do everything online. We look for information, and then somehow, you know, we upload stuff that we're not supposed to upload. This is something that got us very interested in the security solutions, which are not supposed to somehow take data outside from boosting their detection or any other reason. Some vendors who are probably visiting your company or other companies and take the data with them. And some hackers, yeah, we all love them. So what we want to focus about today is, just like I told you a few minutes ago, is the security solutions. So when we were doing our research, regular research, malware, we found out that some of the zero detection are the most interesting ones. And the reason is because sometimes when a product doesn't detect something, it means that it's either garbage or something that could be Fancy Bear, Lazarus, other APT groups, something that is interesting and could be gold. But also, from that garbage that we found stuff that was actually gold but unrelated to APT. So what we did, after we found a couple of scenarios, we decided that we will build a tool around it so we can actually prove that it is true. One of the starting points were paid services online, multi-scanners, sandboxes, stuff like that, where malware resides usually. Some repositories to find maybe some additional pastes or code, which was actually exfiltrated somehow, and some other sources, which I will show you in just a minute. From the building blocks is our expertise in malware research, some Yara rules to filter out the binaries that we download, and some data science to actually prove that it's right. And then the goal was actually just prove that data is being unwillingly exfiltrated. Here's an example for you. This is some personal and confidential information, and it wasn't from World War II. It was a few months ago when we started presenting that presentation. May 12, this is just a general question. Anyone ever bumped into some of that information online when they were looking for malware? Yeah. Okay, good. I was just very curious if someone else was. So to find that, all you need to do is look for the word message in a sandbox called Hybrid Analysis. So we contacted Jan Miller, who was the co-founder of Hybrid Analysis, and we were asking him, what the fuck? You know, how did he get there? And he said, well, you know, sometimes it happens. Sometimes people upload stuff, they think it's malware, and it's not. Yeah, but we think it's being uploaded automatically. He was like, okay, this is interesting. Why won't you search for other stuff on our database, and we can actually continue with the work together? And that's what we're doing at the moment. We're trying to remove that information, trying to help those who got their data mistakenly out there. So, I mean, services are helping these companies. Now the reasons, you know, the usual reasons. Of course, we want to focus on one reason, and the security solution. So we found many other stuff. I won't go one by one, but what we try to do is link between them. Try to understand if it's only emails, or it's only code, or only dumps, or something is just, you know, automatically firing stuff outside because it suspects this is malware. Possible feeds where this data can be found as a brain candy for you guys is either code repositories or open source, the ones you know, script and paste repositories. Some of them, by the way, you will have to pay in order to get access to the information. The malware repositories, the multi-scanners, online sandboxes, and sometimes in social platforms. Sometimes it's already there. Regarding YARA rules, so we had to somehow filter on the information that we had, mainly around binaries. If it was text, we used some regexes and stuff like that, but when we wanted to filter out the emails, for example, so we crafted some YARA rules. For those of you who don't know what YARA is, it's a coding language to filter binaries, mainly. And here's an example for one of them. So this is for an email. So you can see that the name of the rules in the headline, and then curly brackets, and then you have to have the variables where strings are, and the conditions where you actually pick what you want from the strings. So over here, for example, we have EML 1, 2, and 3, the attachment ID and MIME type as variables, and what I want is actually all of them together, that will reside in that binary file, and then attachment ID and MIME type and file size larger than 300 kilobytes. Anyone has any idea why I want the file to be larger than 300 kilobytes? Anyone not hungover for yesterday? Anyone is not asleep from lunch? Yeah, it's easy. We're looking for stuff with attachments. Yeah, but still, sometimes it also goes for threads. So we found some very interesting stuff around threads, and some of them were VPs that of like large companies, Fortune 500, were contacting each other about some interesting information, and that also captured that. So we added that for the attachments and for the threads. Another interesting YARA rule that you can actually take as example is for the Outlook, which is non-text but more binary, and then I will have to use the first variable as the opcodes. And for those of you who are really interested, if you actually don't want to use like the straight opcodes and you have some opcodes that you actually don't know what they are, you can use question mark, either 1 or 2. Right, Jacob? This is like school for you here, you're falling asleep. So for the collections, we actually searched the feeds to get the information, listed the hashes from the results, downloaded all the undetected samples, filtered them using the YARA rules, in that example the emails, and sent a match to a pipeline, which Dani will explain about.
So we started with a pipeline because we said, okay, we found 1 email, 2 emails, 3 emails. It's not scalable to go over every email that you find. So we wanted to see how we can scale it up and just get a big feed of interesting artifacts coming in. We start with some RSS feeds or JSON feeds. Each data source has their different feeds, whether it's a paid one or a free one. So we aggregated everything. Had an AWS Lambda function, pull it twice a day, just query and get all the interesting things. We got the hashes, went into a queue, and we had some worker instances downloading the samples or the paste or whatever we found from the feeds. We stored it. We used the EMR with those Spark scripts to clean out HTML tags and a lot of things that we wanted just to get like the text left. Okay, so this is the interesting part. We had an email queue with a custom parser. We had a subject, language, geolocation, and attachments. 1 sec, sorry about that.
He needs the zip from the vodka.
Mm-hmm. Thank you. Okay, so attachments were really the interesting things, especially if they were password protected, which was, a lot of them were. We didn't track anything, but we knew what was in there. Spam filter, about 50% was spam. Viagra, the best feature for the filter, filtered out about 70% of our spam. We used Apache Tika, great library based on Java, can extract everything from almost any file type, text and metadata. So we had a small pipeline just to do some basic NLP. We stemmed everything, took out stop words. Named entity detection, we got names of people, roles in companies, monetary values. Topic modeling to get main topics from each email. Was it financial? Was it trade? Was it health? And store everything in Kibana. So this is a sample of about 1,000 emails. You can see that that's about 5 companies in there. A lot of interaction, and we can see the source of the leaks. Global problem, worldwide, it's not one product in one country. So we had a demo. Problem that last time we did a demo, one of the vendors contacted us and asked us to redact a lot of things. So we will redo it and we will upload the demo and somehow send it over to everyone. Questions?